Right, good afternoon, everyone. Uh, I'm going to go over the homework I gave you last time. I'm just hoping that, if I'm not mistaken, that. All right. So the first question, in fact, you are given a linear and a quadratic function. The equation of the linear, it's a general equation. F of x plus ax squared plus b. Please take note that instead of a q there is a b there. Sometimes you can have any other letter besides a Q, right? And then g of x is parallel to the x-axis, right? And the value of x there is a 2, y is a 3, okay? Right, so 8.1, write the coordinates of point A. So point A is here, and there is a point there where x is 4. So since our y-axis is an axis of symmetry, the coordinates of A are going to be x equal to -4 and y equal to 0, right? Then the coordinates of B, which is this point here, right? We need to determine the coordinates of that point. Now, if you want to find the coordinates of B, you may have to do the calculation, okay? You may have to do a calculation because the value of y here is going to be a 3, but we don't know the value of x. So we need to determine the value of x there. Okay, so just give me a second. I just want to recalibrate. So f of x is equal to ax squared plus b, right? So in that case now, we may have to find the equation. Okay, we may have to find the equation because there is no other way that we can be able to find the value of x here except by substituting into the quadratic function, and we need to know what is the equation of the quadratic function. Right? We don't know the y-intercept, so we don't know the value of b. Therefore, it will be better to use f of x equals a times x minus x1 times x minus x2. We can only use the turning point form because we don't know the value of y at the turning points here. Therefore, I'm going to use the coordinates at that point. So I'll put y equal to 3. I need to calculate a, right? So I'll put 2 there, minus x1 is going to be minus 4, and my x there is a 2, my x1 is 4, my x2 is 4. So the objective uh, is to calculate the value of a. So the 3 equal to minus 12a. Therefore, a is going to be minus a quarter. All right. So that's how I will calculate that. Then now I need to determine what is the value of b. Right. So to find b, which is this value here, right, I can just go back and substitute the value of a here. Substitute x1, substitute x2, and then use FOIL. And here you're not supposed to substitute any value there. So I'm going to do that. Let me do it on the next page. So my equation is going to be f of x equal to my a is minus 1 over 4, x minus 4, okay, times x minus 4. I want to determine the equation. So that will be minus 4 times x plus 4 times x minus 4. So this will give me f of x equal to minus a quarter times x squared minus 16, which I can simplify as minus 4x squared plus 4. So that will be f of x. So that's the equation of f of x. Okay? Any questions so far? Any question?
No, sir.
I hope that you are aware that to find the coordinates of B, it's more complex than to find the coordinates of A. To find the coordinates of B, you need to determine the equation for f of x. So I have done that, right? Now that I know the equation,
Sorry, sir.
yes,
So why can't you find B the same way you found A? Why do you have to use the equation?
okay, I see what you mean. I didn't see that. Okay, I didn't see that. We could also find the coordinates of B without the equation. I didn't see that initially. Okay, I didn't see that. That's why I decided to find the equation. But you can also find the coordinates of B without finding the equation, because we have an axis of symmetry to the y-axis. So if x is 2 here, it means there y-axis is going to be minus 2. I didn't see that. I didn't see that, honestly speaking. All right, so,
Sir,
yes.
so can you please go back to the previous slide where you worked out B? Alright, thank you.
Is that okay with you?
That's fine, so you can carry on.
Okay, so if I substitute, okay, I'll come to the easiest method of not doing any calculation. So if x is equal to, so y is equal to 3 there, here, y is 3. Therefore, I can put 3 there, and then I have to solve this, okay? So I'll get minus 1 equal to minus the quarter x squared, and this will give me 4 equal to x squared. And then eventually you get x equal to plus minus 2. Then you get x equal to negative 2. Therefore, at B, x is minus 2 and y is 3. Right? But the working out would be a longer method. Okay? I didn't see that I could just use my axis of symmetry like how I got the coordinates of A. So if you use the fact that the y-axis and axis of symmetry means the distance from this point to the y-axis is the same as from the y-axis to B. Therefore, the coordinates of B are going to be x is minus 2 and y is equal to 3. All right? Are you following there?
Yes, sir.
Okay. Then the next question, 8.3, says if point C is the reflection of point A about the line y equal to minus x, find its coordinates. So point C, right, it is a reflection about the line y equal to minus x. Now the line y equal to minus x is this line. That will be the line. Alright? Find its coordinates. So if we reflect point A about this line here, we know that the value of x here is minus 4. The value of x is minus 4, the value of y is a 0. Alright? Now, based on that, the rule of reflection about the line y equal to minus x is going to be this one here. So if you've got a point and you reflect it about the line y equal to x, y equal to minus x, right? Well, in most cases, in that case, you will have the x being positive, the y being negative. So what happens is, if say your x is negative, if you reflect it, you end up getting the new x coordinate being a y, and that y, the new y being what? A negative x. So there's a switch which takes place. Right? Now, in actual fact, so if you reflect, so remember the coordinates of A are x is minus 4 and y is 0. If we reflect that x, okay, to point C, right, the x will become a positive, okay? The x is going to become a 0, rather, to become a 0. The new x value becomes a 0. Okay, based on reflection about the line y equal to minus x. If it was the line y equal to x, you just switch the x and 1. So in this case, the y value, the x value becomes 0. So we are reflecting this point about this line, means it will not get to somewhere there. Which means the y, this x value becomes a y value and its sign will change to become a positive. So our line y equal to minus x, it's a line of reflection. Okay? If the
Sir,
one...
how do you determine, sorry sir,
Yes.
how do you determine where the line y is equal to minus x is going to be?
Okay. All right, it's a good question. What you need to know is that the line y equal to minus x, it is a straight line which passes through the origin, and it has a gradient of -1. Okay? So the line y equal to minus x, if you were to sketch it, it will look like the one that I just drew for you. There is also another one, which is the line y equal to x, which goes that way, with a positive gradient. So this one would y equal to minus x, and that one would y equal to x. These straight lines, they are well known in maths. In actual fact, in grade 9, you should have been introduced to those two straight lines. The line y equal to minus x and the line y equal to x. They are just basic straight lines with a y-intercept which is equal to 0. In the case of y equal to minus x, its gradient is -1. The line y equal to x, its gradient is a +1. So you should be able to sketch them and then answer questions based on reflection of points about those lines. So I would just say it's basic knowledge in terms of how the line y equal to minus x looks like. Right. Okay, this is how I'm going to say it again. If you are going to reflect a point about the line y equal to minus x, if a point is here, right, it means that if you reflect it about the line y equal to minus x, it has to be on the y-axis. The image of that point is going to be on the y-axis because the distance from here to the line y equal to minus x must be the same as from the line y equal to minus x to that point. So the question will be, what is the value of x here? The value of x You just switch this value, it becomes the x value. Alright? The y, sorry, the x value which was negative, it changes because of the nature of the equation. So because the equation is y equal to minus x, so if an x value was negative, it becomes a positive y value. Therefore, this minus 4 becomes a positive y value.
Ew. Ew, that.
Hello?
Oh,
Are you
I
following?
understand now, sir. Yes, sir.
All right. So our coordinate of CRX is 0 to y equal to 4. Right? Then 8.4, if f of x minus k has no x intercepts, determine the values of k. Now, this question now, it's a higher order question. What you need to know is that f of x minus k, okay, this k here, it's a y value. It represents a y value. Or it represents a specific value that we are subtracting from f of x. And f of x is y. So we are subtracting two y values. This is our main function. We subtract k from it. Okay? But the question is saying if f of x minus k has no x-intercepts, which means f of x minus k, it's a new graph that has no x-intercepts. So, what values of k will make us have, or will make us have this graph that we have here, being converted to one which has no x-intercepts, because currently it has got x-intercepts. So, how can it not have x-intercepts? That's what the question is asking. What value of x, or rather of k, will make this graph to not have any x-intercepts? All right, now in this case, I want you to be aware that the only way that you cannot have x-intercepts, right, is by, if you move this graph, I hope you know that the y-intercept here, it's a 4. Okay, I got that here when I did the calculation for the equation. Right? When I found the equation, this value here is our Q value. Okay? So that value is the value of y at the turning point. So if we don't want the graph to have any turning points, the question is, what will be the values of k that will make that possible? Right? Now, before I tell you how I can determine the answer, do you agree with me that if we don't want to have any x-intercepts, we can't move the graph up, but we have to move the graph down? I'm going to repeat that. Do you agree with me that if you want to have the graph, this graph here, the graph of f of x, if you want to make sure that that doesn't have any x-intercepts, the only way is to move it down by a specific number of units. Okay? You can only move it down by a specific number of units. The question is, by how many units can we move the graph of f of x so that we won't have any x-intercept? That's what the question is asking. It actually relates to vertical shift for you to be able to get the value of k. And the value of k is a y value. So can someone tell us, because I don't want to just give you answers throughout, what value of, or rather by how many units can we move this graph of f of x downwards so that it won't have any x intercepts?
Five.
By how many units?
4 units.
Okay, let's say we move it by 4 units. If we move it by 4 units down, it means we'll end up having a graph which looks something like this, right? It means we are going to have an x-intercept here, which is equal to 0. So what that means is we are supposed to move the graph by more than 4 units downwards. Okay? We have to move the graph by more than 4 units downwards. But our expression here, if you look at our expression, it has got a minus. So the value of k is not going to be a negative value, it has to be a positive value. Therefore, the value of k, which will make us have no x-intercept, is going to be k must be greater than 4. Okay? K must be greater than 4. So that, okay, I'll just give you an example. Remember, the general equation of that graph is minus a quarter x plus 4. So if I subtract 4 from that graph, I'll get y equal to minus a quarter x plus 4 minus 4. And this will give me minus a quarter x. And if I sketch minus a quarter x squared, right, it will be like this graph. But I want the graph to have no roots. Therefore, I have to subtract a value here that is more than 4. Okay? For us to have no roots. So this will be our solution. K must be greater than 4. So whatever number of units you move the graph down, they have to be more than 4 units downwards. Do you hear me there?
Yes, sir.
All right. Avumile, let me go back to your... Huh?
Can you please repeat it? Yes.
Okay, wait. All right. Avumile, for 8.2, all right, I forgot to answer 8.2. All right, I'll come back to 8.2. Let me carry on to 8.4. What I'm saying is, if you want the graph of f of x to have no x-intercepts, it means you have to move it downwards by more than 4 units. If you move it downwards by 4 units, it will get to have a turning point which is on the x-axis. Therefore, we are going to have one x-intercept here, which is going to be x equal to 0. Okay, we are going to have one x-intercept, which is x equal to 0. In this case, we don't want the graph to have an x-intercept. Therefore, we have to move it down by more than 4 units. Okay, I hope I have answered that. All right, let me come back to Avumile's question. Write down the equation of g of x. Now, g of x, it's a straight line. That's straight line there. The value of y is a 3. The value of y is a 3. So the equation is going to be y equal to 3. So this is straightforward. The equation for g of x is going to be y equal to 3. Any question? Avumile, I just hope that I've answered your question. That's a very straightforward question. The equation for g of x is y equal to 3. Then, but who has got any other question?
No, sir.
All right, let's move on to the next one. Okay, now the question says, describe f of x. Okay, describe how f of x must be shifted so that it intersects g of x at only one x point. Right? Describe how f of x must be shifted so that it intersects g of x at only one x point. What that means is, at the moment, the straight line, this line y equal to 3, and the quadratic function, they are intersecting at 2 points. So the question is, how can we shift f of x, which is the quadratic, so that we will only have one x point? Okay? The only way you can do that is to move the graph of f by 1 unit, because y is 4 here. We move it by 1 unit down so that it will look like this. It will look, yeah, to look something like that. Okay? So the answer there is by shifting, by how, okay, by shifting f of x 1 unit down. That would be your answer. So if you move it downwards by 1 unit, it end up by shifting f of x 1 unit downwards. Okay? So you just have to move f of x by 1 unit downwards. So that's straightforward. Then 8.6a. Use the graph and determine for what values of x is f of x times g of x less than 0. Right? So we want f of x times g of x to be less than 0. Okay? Now, for us to have a product of f of x and g of x being negative, it means that either f of x is negative, g of x is positive. Right? So we can have a case where this one is a minus, that one is a plus. We can also have a case where this one is a plus, that one is a minus. Right? So the only way we can get that answer, right? Remember, the graph of G will always be positive. The graph of G will always be positive. It will never be negative because it's a straight line. So the y values for G will always be positive. Okay? And the other thing as well, the equation for G, we can also write it as G of x equal to 3. Okay? We can also write it as G of x equal to 3 if we use function notation. So, we can never have a case where G of x is negative. That's not possible. Which means my f of x can never be positive. So this one is out. G of x can never be negative, therefore f of x can never be positive. Alright? So what that means is, we can't look at the first quadrant and the fourth quadrant, because in that case, the y values, okay, please take note here, the y values for f of x are negative in the fourth quadrant. Alright? The y values for f of x are negative in the fourth quadrant, but the y values of f of x are positive in the first quadrant. So we can't have a case where we deal with the first and the fourth quadrant because g of x is positive in the first quadrant. All right? But in the second quadrant here, the values of g of x are negative, whilst the values of f of x in terms of the y values are also positive. But from this point going towards the left, the y values for f of x are negative, whilst the y values for g of x are positive. Therefore, the answer here is going to be x must be less than minus 4. Okay? X must be less than minus 4. Be aware that from this point going down, the y values for f of x are negative. From this point going up, the y values of f of x are positive. Therefore, we don't want both f of x and g of x to be positive because in this case, g of x is always positive because it's a horizontal straight line. G of x can never be negative. It's always positive. So we can only get our solutions when y is negative. That is when f of x is negative. Any question there before I move on? Any question there?
No, sir.
Okay. Then let's move on to the next one, 8.6b. Alright, so we have f of x minus g of x must be positive. Okay? What this means is the graph of f, okay, the graph of f minus the graph of g must give us a positive answer. Okay? Which means both must be positive or both must be, in this case, well, one may be highly, what can I say? One can be, in fact, both can be negative, but if you are to get a positive, it means that this one here, f of x, it has to have larger values of a negative, whilst g of x will have smaller values of a negative, which is not possible because g of x is always positive. G of x is always positive. For this graph, it's always positive. So g of x can never be negative. What that means is we have to look at where the y values for f of x are also positive, so that we get a difference between the two that's positive. And we can also look at where the graph of f is above the graph of g. That interval where f is on top of g is the answer. Okay? By the way, this inequality can also be written as f of x is greater than g of x. If you take the minus g of x to the right, it can also be written like that. Okay? So, all we are saying by this is that the graph of f is above the graph of g. So that is only true from this point to that point. So in that region there, that's where our answer is. And our answer for that is going to be minus 2 less than x is less than 2. That will be our answer.